Friends, welcome to lecture 16 in biopharmaceutics, and we are starting a new chapter in biopharmaceutics, and that is in vivo in vitro correlation, which is also called or abbreviated as IVIVC. The topic of today's lecture is Introduction to IVIVC and its various levels. Outline for today's lecture: we will discuss the introduction to IVIVC concept, the in vitro in vivo correlation. We will discuss the FDA and USP definitions of IVIVC, and then various levels of IVIVC correlation, including correlation A, B, C, multiple level of correlation C, and correlation D. So what is the idea of IVIVC? So basically, this idea is between in vitro and in vivo studies, and that correlation could be used for various pharmaceutical dosage forms, and it has emerged as of very high interest for various pharmaceutical industries, academia, and regulatory authorities at the same time. And mainly this idea of correlation is applicable for various dosage form, and what it does basically that this idea revolves around this significant purpose that it could act as a replacement for in vivo bioavailability studies. If there is a correlation been found between for any pharmaceutical dosage form, that correlation could be used as a replacement for the need of any in vivo bioavailability studies, and it could help in biowaiver too. Now, biowaiver is a concept which is applicable in the situations when the drug regulatory authorities allow or permit to skip any in vivo bioavailability studies on the basis of previously performed results of such bioavailability studies, and they only rely on in vitro studies which are able to correlate with in vivo results of the previous studies. And so in that scenario, it is this biowaiver is extremely helpful to not to conduct the in vivo studies and still to go for conduct certain changes in the dosage form, to bring about certain change in the dosage form. So IVIVC has particularly got significance in that connection, and it is also used in determining the resolution specifications and to validify the resolution methods, as we know that there are various resolution methods or apparatuses which are used for determining the in vitro resolution, and every method has its own significance. It uses specific criteria and conditions, and how successful that method is, that could be determined if it is able to correlate well with the in vivo bioavailability studies. And so in that situation, a particular resolution method or apparatus can be validated with on the basis of the previous in vivo availability studies, and by finding a correlation, a successful correlation between the both. So when we look at the definition of IVIVC, then there could be two possible definitions. One is the USP definition and or United States Pharmacopoeia definition, and the other one is FDA, which we will discuss later on. And so first of all, the USP definition. So according to this definition, IVI relationship between a biological property or a parameter derived from a biological property produced by a dosage form. Like let's suppose we just decode this part of this definition till this dosage form, that biological property which is derived from a biological property, so of a dosage form. So as we know that any dosage form is destined to get absorbed, particularly if you're talking about so the oral dosage form. So when it gets absorbed, gets bioavailable. There is EV under the curve, which could lead to calculation of bioavailability, which is a biological property. So one biological property, that is absorption, is leading to another parameter derivation, which is area under the curve or bioavailability, which is dependent upon this biological property of the dosage form. So moving further on in this definition, they say that this is a rational relationship between a biological property or a parameter which is derived from a biological property, means absorption of a dosage form, and a physicochemical property or characteristics of the same dosage form. If you look at the dissolution, that is a physicochemical property of a, or you can say a pharmaceutical property of a dosage form. It is not typically a biological property. Dissolution could be considered as a um, pharmaceutical property of a dosage form, physicochemical property of a dosage form. So basically, what the USP definition is telling us that it is establishment, IVIVC is establishment of a rational correlationship between bioavailability, which is a biological property, and physicochemical property, means the dissolution. So this correlation is what you call IVIVC, in vitro in vivo correlation studies. And if you look at the definition provided by FDA, according to this definition, IVIVC is a predictive mathematical model describing the relationship between an in vitro property of a dosage form and a relevant in vivo response. Generally, the in vitro property is the rate or extent of drug dissolution or release, while the in vivo response is the plasma drug concentration or amount of drug absorbed, aka bioavailability. So, correlation levels of IVIVC. So FDA provides 5 correlation levels, and the basic idea behind correlation levels is to reflect the capacity of the in vitro correlation to reflect the complete plasma drug level time profile, which will result from administration of the given dosage form. It means that when that specific given dosage form is administered, and what would be its possible plasma level time profile, uh, irrespective of the fact that it is not being determined, but the in vitro dissolution is capable to reflect the same profile through its values, or the in vitro dissolution values, or whatever you get along with the time. So basically the idea of the correlation levels is capacity of every correlation, and it is showing whether this correlation is strong or weak. Various identified levels are classified as correlation level A, B, C, multiple correlation level C, and correlation level D. So these are the 4 or the 5 various levels which could be identified based on the level of the correlation or the capacity of that correlation, reflecting the correlation between in vitro dissolution profiles and the in vivo drug concentration time profiles. Level A correlation. This level of correlation is the highest category of correlation and represents a point-to-point relationship between in vitro dissolution rates and in vivo input rate of the drug from the dosage form. Now it means that there would be a maximum correlation, you can say a similarity in the patterns or in the profiles of the in vitro dissolution and the in vivo bioavailability profiles, which are usually also known as you can say the plasma drug concentration versus time profile, but usually we are talking about bioavailability. That is something else. So what it says or it suggests that in case of maximum correlation between in vitro dissolution profile and in vivo bioavailability profiles, that kind of correlation would be considered level A. That would be a maximum correlation that could be found. So important task is to calculate the percentage of the drug which is absorbed. So that could be calculated by using various methods, and two methods are model dependent techniques, while one is model independent one, which is also called numerical deconvolution. So the model dependent techniques, Wagner-Nelson procedure or the Lou-Riegelmann method. These two are model dependent techniques, while the model independent technique is numerical deconvolution. Just know about these various methods, and whenever the time will come, we will discuss about these methods in detail, but later on when we will discuss this thing in more detail. Correlation. In this one method of correlation, for this level of correlation, usually the analysis method used is statistical moment analysis, and in this level of correlation, the mean in vitro dissolution time, MDT vitro, of the product is compared to either mean in vivo residence time, MRT, or the mean in vivo dissolution time, MDT vivo. Two parameters regarding the in vivo dissolution or bioavailability are available to get compared with in vitro dissolution time, that is mean time. Simple is that in this method, mean values are compared with each other, except instead of point-to-point correlation, and on the basis of the mean values comparison, it is determined that whether it is a level B correlation. There is a certain level to define that value, and the in vivo values could be two: the MRT, which is the mean residence time basically, and in vivo dissolution time, which is the MDT. So how long it takes to get dissolved within the body, that mean value, or how long it takes to reside within the body, that mean value. So this is compared with in vitro dissolution time, and this determines the level B correlation or whether it is or not. Level C correlation, and here one dissolution time point is compared to kinetic parameters such as area under curve, Tmax or Cmax. What happens that what T 50% or T 90% is showing? This is showing the time point in respect to dissolution, the time point when the 50% resolution has completed, the time point when 90% resolution has completed, and thus similarly it can go on. And then the various time points are compared with various parameters, like that could be area under the curve getting compared with Tmax, or getting compared with the Cmax, or the various concentrations of the drugs. So what we see that this is the weakest level of correlation, as partial relationship between absorption and dissolution is established, as we can see that though the dissolution time points at which various up to certain percentage dissolution has occurred, that is being compared to a parameter which obviously has no direct link with that. So this is a partial relationship. Like if I explain it a little further, in case of level A correlation, we see that point-to-point correlation is being observed, while in level B we see that mean values are being compared with each other. Here there is not such a scene, but simply the certain time points at which dissolution has occurred to a certain extent, that is being compared with various pharmacokinetic parameters. That could be any parameter which you pick up, and so this is a partial relationship, and this is also weakest level of correlationship, and usually this is helpful or useful in early stages of formulation development when pilot formulations are being selected. Level D correlation. Level D correlation is a rank order and qualitative analysis and is not considered useful for regulatory purposes. Now we can see that it is being mentioned that it is a qualitative analysis, not a quantitative one. It is only used for the observation purposes. So when it is used most possibly. It is not a formal correlation but serves as an aid in the development of a formulation or processing procedures. Like I just mentioned that it is not a quantitative measurement, so it is not that useful. It is only used by the experts during developmental procedures and of a formulation for observation purpose, and it has no quantitative value. It is not like the initial 4 levels.